manageable piece.
All set? Okay. Welcome, everybody. My name is Chris Holmes. I'm a mentor with FRC 1073, the FORCE team. And I'm going to talk today about our scouting solution that we put together. We have a strategy team. Strategy's always been, we love playing the games. And we've tried all different methods of scouting and strategy. We've done the paper. We've developed some different apps. We had a good Java app for a while that worked. Um, but we recently converted over to a web-based scouting solution that uses a Raspberry Pi as a web server, and we cable that to 6 scouting tablets. So everything that I'm about to show you is available on our website, frc1073.org. And if you go over to the resources menu, you'll see Scouting app, and that'll bring you to the page from which I'm going to work and present everything today. So it's all available. It's all there. I'll kind of just talk at a high level about everything, but the details are all in there. And what we're going to cover today is the parts you need and how to set it up and use it. So I'll begin. The first section here is how you set up a Raspberry Pi web server. We'll come back to that. But first, let's scroll down to the second session, and I'm going to go right to the last slide, assemble the hardware. Let's take a look at this thing. What do we need, and how's it going to work? So basically, here's the layout. And I'm just going to scroll down to the picture here. So starting at the top with this red and black thing, that's our 12 volt to 120 volt converter. So that goes on to the robot battery. I'm sure everybody's got one of those. So the robot battery is the only thing missing here. But plugged into that is our Raspberry Pi in this black metal case. And coming out of the Raspberry Pi is an Ethernet cable to another black box, which is our 8-port switch. And also you'll see a USB port of the Raspberry Pi is what's powering the switch. So that was important to find a switch, an 8-port switch that could be powered through USB. I guess it's not that important. We could have just plugged that into the converter as well. But we like to have a laptop and a stands as well, and sometimes the laptop might need power. So it's nice having that extra power plug available on the converter. So we thought this was handy to be able to get a switch that could plug into, be powered off of the Raspberry Pi to try and consolidate our power needs. Out of the port, so like I said, the Raspberry Pi is plugged into one Ethernet cable, and then 6 other ports are plugged in through longer Ethernet cables to the 6 tablets. And the key here is you need tablets that have Ethernet support, because you can buy these little adapters. I think they're like 12 or 15 bucks. But the Ethernet cable plugs in on one side, and out the other side is a micro USB port that we could plug, that plugs into our Android Galaxy tablets. So any tablet that supports Ethernet and plugs in somehow, some way with an Ethernet cable, that's perfectly fine, because there's nothing special about these tablets other than the fact that they can connect to Ethernet. That makes this solution work. Because what happens, and we'll go into the details here, is the Raspberry Pi becomes our web server, and all the tablets have to do is point a browser at the web server, and the scouting app comes up. So that is it from a hardware perspective. And you can see we've got 3 red tablets, 3 blue tablets. The cases were red or blue. That's great for designating who's scouting who. So that's the setup, and it fits in a suitcase. We carry it. We can tuck the Raspberry Pi and the battery and the switch under a seat, and it's out of the way. My previous session was about developing the web pages, but there was a question in there on whether you could use a laptop rather than a Raspberry Pi, and that works fine as well. In fact, it might work better because the laptop's going to have a faster CPU that can process the web pages, the web server faster. The Raspberry Pi has worked well for us. We've seen a little delay every now and then when you've got 6 scouters trying to interact try and submit information into a Raspberry Pi at the same time, the web server. But it hasn't been prohibitive. They usually just have to wait and click again, and everything works. So these are the components you need. Um, and the Raspberry Pi is the key. It's kind of the brain of the whole thing. So I've got instructions here on how to take a Raspberry Pi, and we set up Ubuntu OS. You can install any Linux OS, I guess, but these instructions will cover the configuration settings that are found on an Ubuntu. And I installed 20.10, 20.4, um, uh, whichever Ubuntu had on their website. So I'll click on this, and we'll get into the details here a little bit. But yeah, so here's a link to the Raspberry Pi kit that I purchased. Again, any Raspberry Pi with an Ethernet cable um, will work, and USB ports. Here we go, 20.4. So I followed. I went to the link here at Ubuntu. They've got a great, easy instructions for how to install Ubuntu on a Raspberry Pi. Followed them, and they were flawless. The trickiest part is once you've got Ubuntu installed, your Raspberry Pi is just going to ask for an IP address when you plug it in. So I plug it into my home network, and it's going to ask, it'll request an IP address from my router. And so in order for me to connect to it, you gotta figure that out. And they provided some instructions. How I did it is I logged into my router, um, and that's a little bit important. And you can see here in the details. So in my router, I notice that my IP address range that my router hands out starts at dot two. So my home network is 192.168.1 dot something. So that's my home network, and that's a private, that's a private subnet. Um, Everybody's home might have that. All routers like the one I have serve that, and you can change it. But that's what my home subnet is. So I wanted to pick an IP address to configure statically in this Raspberry Pi, so that I don't have to keep looking for it. Right. Once I found it, I connect to it, and then I'm going to end up changing it in a future step. And that's useful so that I can always reach it. Um, so going into my router, seeing the range, as well as once in there, you can list all your current connections in your home. And I think it was labeled Raspberry Pi too. It was really, really easy to find. So once I found the IP address, which was right here, then I was able to log into it. And these instructions are covered in the Ubuntu page, but I duplicated them here. Um, so how do you connect? There's two ways to connect. You can download this putty.exe program, and I can show you that. I've got that here. In fact, that's it right there, but I'll launch another session. So you can go to that website that I showed the link, right click, save as the putty.exe for your laptop. And then you type in 192.168.1, and 38 was the IP address of my Raspberry Pi originally, but I've since changed that to a static IP address that's outside of the range of my router, and that's why I needed to know that my router gives out IP addresses from .2 to .50. I needed outside of the range, but I still needed to stay within the subnet of my home. So I gave it 75. So if I do that and I click open, it asks me to log in as, so I type Ubuntu. And the first time you log into a Raspberry Pi, the password is Ubuntu, so you'd type that. But and then they ask you to change it. Since I've already done that, I'll type in my new password. And now I'm logged into the Raspberry Pi. So PuTTY is one way to do it. Another way, which is this terminal window, is the Windows subsystem for Linux. So I have a Windows laptop, and I cover that here. There is a Windows and Linux for years have been separate operating systems, competing operating systems, but recently they've collaborated. So Windows collaborated with Ubuntu, and now you can install a feature called the Windows Subsystem for Linux on your laptop. And that allows me to just click on this link, pop up a terminal window, and I'm running here. Let me get out of the Raspberry Pi. Now I'm on my laptop, on my in a Linux shell on my Windows laptop. And so if I up arrow, you can see I type SSH Ubuntu at the new static IP address for my Raspberry Pi, and I can SSH into it. But I'm getting ahead of myself here. So right now, when you've freshly installed it, you find the IP address in your router. You can log into it. As we've shown you, change the password, and now you're in. And then the next step here is a quick Linux tutorial for those who've never been in Linux, a few commands to understand. Um, but if you don't want to become, if you're not software developers, you're just trying to put this together, you can skim through this. And all the commands will be spelled out in here. So the next step I recommend, once you're in the Raspberry Pi, is to update the software on it because it'll have patches, it'll have security fixes. So run this app update command, and you have to run it with the sudo in front of it because this is an administrative task that we're doing. So you're going to make system changes, you're going to install software. You need to do it as the super user, the super user in Linux, and that's done by pre pre what am I trying to say? Prepending sudo to the front of all your commands. So this command says, do this task as the super user. So this app update command says, go out to the Ubuntu websites, servers, and see if they have any new software posted that has fixes that I don't have yet on my Raspberry Pi. And the first time you do this, there'll be a bunch. Then the next command says, all right, install. I'll upgrade my Raspberry Pi with all of these patches. So this is a good thing to do once a month, every now and then, to make sure that you have the latest software, all your bug fixes, all your security patches on in your Linux OS. So just quickly run those two commands. You'll be prompted, hey, I'm going to install all this software. Sure, just hit yes. Um, and it will go through and install. It might prompt you, it might tell you have to reboot if it's going to change the kernel, the operating system. If it's got a new operating system, it'll tell you to reboot. Go ahead and reboot. And then you're ready to go. And then the next step is I recommend installing a text editor because we're going to have to edit some files on here. Even just to configure the static IP, you're going to need an editor to edit a file and be able to change the static config. If you can also, the Raspberry Pi, you can also connect a monitor and a keyboard and a mouse, and you can have a desktop. And then you can, make changes. If you're familiar with the graphical tools, you can do that. But I'm going to show you how to do it quick and dirty in a text editing fashion. So at a very low level editing fashion, you're going to look like an expert. So install the Emacs program because I like Emacs. It's a very nice editor. It's excellent for development work. So I recommend that one. And I give a quick tutorial on how to use this program called Emacs if you've never run it before. So run Emacs-NW, which means don't try and pop up any windows because I'm SSH, which stands for secure shell. I'm SSH'd into you remotely, so there's no graphical connection. So don't try and pop up any windows. And for this tutorial, let's create a file called hello.txt. So when you run that command, you're going to see a window much like this. And you'll be in the editor. Your cursor will be in the editable area of the screen. Type whatever you want. I type hello, Dean. And then to save and exit, to save the file, you're going to hit Control X, which how I usually put my pinky on the control, hold down the control button with my pinky and type X. And that will move your focus from the edit window down to the bottom control bar window. And then follow that up with a control S. And again, hold your pinky on the control and press S. So control X, control S, and that will save the file. So now the file will be saved. You'll know it's saved because these two asterisks will disappear. They will turn into hyphens. That means the file has been saved. And then to exit the file, control X again, followed by control C. The control C will get you out of the file. And now you're back into the terminal window, and ta-da, you've just successfully edited your first file. So now that you have a text editor and you know how to use it on your Raspberry Pi, let's configure that static IP address. So the details are in here. Make sure they align with your details. Pick an IP address that's outside of your range, but still on your network. So I'll show you that down here. What you end up doing, you have to use the sudo command. We'll use the emacs-nw again, use your editor. And then this is the file in Apache Ubuntu that you have to edit to change your IP address. So in there, you will see dhcp4 equals true. So dhcp is the server. It's running in your home right now, likely on your router. It's what hands out IP addresses. It's this works at school, this works at the coffee shop, this works everywhere that Wi-Fi is available. That's what Wi-Fi is made possible by, is by our router providing a network, and on that network is a DHCP server saying who needs an IP address. And your phone, your laptop, all are programmed to say, are typically by default programmed to say, hey, I need an IP address. Here's my machine address, my MAC address. I need an IP address so that I can participate on the internet. And so that's what the Raspberry Pi was configured to do at first, was to request that, make that DHCP request. But we want to change it so that we give it a fixed IP address, so that whenever it boots up, it says, this is my IP address. I don't need to ask anybody. If anybody wants to reach me, they can reach me at this IP address. And so that's what this does. So I've made the changes. The changes are in red so that when you cat the file out, you'll see I changed true to false. I configured my address to be 192.168.1.75, and 24 is the net mask. So the net mask is how you define your network. So my home subnet is 192.168.1, and then it can be any number for the last octet from 1 to 255. That's what this net mask says. So a net mask is typically written out as 4 octets. It's typically, this 24 would be 255 in the first octet, 255 in the second octet, 255 in the third, and then 0. And what this net mask is a binary net mask. 255 is 8 bits. 8 ones in binary makes 255. You can check that on a calculator that knows how to convert from decimal to binary. And so 24 is 3 eighths for the first 3 octets and a 0 for the last. And that's how you define the range of your network. The first 3 octets are always 192.168.1, and the last one can be anything. That's what the net mask is saying. So we're defining it. We're saying, okay, we're participating in that subnet, and we're going to be last octet number 75. The next line is your gateway, and your gateway is where the Raspberry Pi will send requests that don't fit in this local network. So if I want to go to Google, Google's address is 1234. So in order to get outside, so Google's not going to be found on my home network. So to go out, I specify, and this IP address is my router. My router is 192.168.1.1. So this is telling the Raspberry Pi, send the request to the router, and the router knows how to get out of my house and to the internet. And the last piece of advice is the name server, and the name server is what translates human readable strings to IP addresses. So if I type google.com in my browser, that gets sent out to the name server. The name server says, the request to the name server is, hey, what's the IP address for google.com? And it will send back, it's this, and it'll give my browser the Google IP address, and then my browser, my Raspberry Pi, the Raspberry Pi would say, okay, uh, let's go to that IP address, because machines only know numbers. Humans know the alphabet. So that's why you need a name server. So I configure the name server. And this is needed because, for example, when you update software, it needs to go out to ubuntu.com. And so in order to find the IP address for ubuntu.com, it needs to know where the name server is. So these are the changes. Just type them in. Make sure the subnets match your network. Make sure the name server. I got this from my router. If you go into your router, you'll see the name server that was given to me was given to my router by my wireless by my broadband provider, by my internet provider. The internet provider automatically tells the router. And so when I went into my router's homepage, I brought my pointed my browser to 192.168.1.1, logged in, and in there I found the name server, the DNS, domain name server IP address, and I put that right in here. So that's it. Save and exit this file. And then if you read the comments at the top of the file, it says this file is generated automatically. So if you do not, it's not going to persist. So if you want to not change this file, you need to create this file with this configuration, network config disabled. Turn that off. Otherwise, the changes here will get overwritten and the Raspberry Pi will go back to requesting a DHCP address. So I edited that file. I used, again, I used sudo emacs -nw that. I had to create this file and I added this content to it. And that's it. Once those changes were made, I typed reboot, sudo reboot, shut down the Raspberry Pi, unplugged it, plugged it back in, it booted back up, and now I could SSH to 1.75. So that's how you configure a static IP. Oh, so I'm jumping around a bit here. So that's the static IP. The next step, and actually the last step on the Raspberry Pi, is now we need to install a web server on it. So we will install Apache 2. And I apologize if people were in the earlier session. I know this is kind of repeating, but we'll be able to spend more time with the scouting app after. I just realized that. So Apache is Apache is a very common web server. Apple.com uses it. Craigslist.com. A lot of internet companies on the internet use Apache. It's very common, and now you're going to have it running in your home. So it's going to, all you have to do is run, sorry, I'm scrolling around, sudo apt install Apache 2, and that will install the Apache 2 software, and it will start it right up automatically. So as soon as you do that, you can point your browser to your Raspberry Pi. So fire up your browser, and you can see here in the picture, I typed 192.168.1.75 in my Firefox browser, hit enter, and I got the default page. And then this page talks about how browsers work, or how web servers work, how they serve files. But what we need the web server to do is to support CGI scripting. And that's how the scouting app is going to work. So in order to enable, so this talks about CGI scripting here, and why we need it. We need to enable that in this web server so that we can add the scouting app software to it. So sorry for the scrolling. We'll go to the next page, which is how you enable CGI in Apache. So you run this command, sudo a2enmod. So this is Apache 2 enable module CGI daemon, CGID. So this will enable the CGI support. And what CGI will do is it allows programs to be run that will create web pages rather than just serving static web pages. And that's what the scouting app is built on, is the ability to dynamically create web pages and take input from the user, and create web pages. So you run this command, it will say enabling, and then it will say to activate, you need to restart the Apache 2 service. But before we do that, we need to make one small edit. So by default, to enable CGI scripting, the web server is going to look in user lib CGI bin directory for those scripts. Whenever somebody, I'll show you up here. If anybody types CGI bin slash index.cgi to run a CGI script, it's going to look on the server on the Raspberry Pi in user lib CGI bin. But in order to keep all the scouting code together, I want to change this location and I want to move it to var www CGI bin because that's close to where that's right next to where the static HTML support is. In the previous page, we talked about the document root where the web server looks for files, and by default, it looks in /var/www/html. So you'll have the HTML directory for regular static web pages, and you'll have the CGI bin for the CGI scripts. So to make this change, edit this file with sudo emacs -nw and then the path to the file, this configuration file for Apache 2. And it's just a small change. It's right in here. Change that user lib to var/www. Save and exit. And now we can restart the Apache 2. And now you have a web server with CGI support running on your Raspberry Pi, and you are ready to go. So the next step after that is we can install the scouting app software. So FRC Team 1073 has a GitHub account. We store all of our robot code there. We also have the Web Scout support. So if you go to the Web Scout repository, the link is right here. You can see the repository. You can see the code. What we're going to do is pull down a copy of that code using the git command on the Raspberry Pi. So let's make a directory first. So by default, when you're logged in, you're in your home directory. Let's create a directory called git. And in there, we will pull down the code from the GitHub repository down onto the Raspberry Pi. So to do that, if you go to the GitHub location, let me jump to there. If you click on this green button here for any GitHub, for people not familiar with GitHub, you click on this and it will give you this path that you can highlight and copy. Control C to copy. That's the path to the repo. Right here in the instructions, I have it. So what you're going to do is type git clone and then that path, webscout.git. And that will go out to the internet, go out to GitHub, pull down all the source code, and copy it in this directory. So when you're done, if you run an ls command, you will see a WebScout directory. And in there contains all of the scouting app code. So inside of the WebScout directory, if you cd into that WebScout directory, you will see 2 directories and 2 files. The 2019 directory is the destination deep space. That was the first year that we developed this code. So that has all of the code. That has everything in the www. Yeah, if you go inside that folder, you'll see www, and that matches with /var/www. So if you copy everything there, it goes into /var/www, and you will have the 2019 scouting app, the Destination Deep Space scouting app, our first scouting app, installed and running on your Raspberry Pi. If you want the Infinite Recharge one, that's in the 2020 folder. And hopefully next year's game, 2022, we'll develop the scouting app for that one, and that'll be in that folder. So that's how this is arranged. So what you'll want to do is cd into the 2020 for Infinite Recharge. Let's get rid of the default index.html page that Apache 2 provides. We don't need to serve that. You can rename it or you can delete it. I deleted it here with the rm command. If you want to save it somewhere, you can use the move command, but I just delete it. And then Here, you can see here, you cd into the Web Scout directory, you change directory into the 2020 directory. If you look in, yeah, I don't know why that doesn't show anything. Yeah, if you do lswww, oh, I see. This is a small typo in my web page here. I think I just typed ls and you saw www, so I need to put a return in here. It's a little cut and paste error on my fault. Um, but then if you do, well, show me what's in www, you'll see CGI bin and HTML, and that matches. If you do an ls of var www, you should see, you might not see the CGI bin. You might have to create that. It's there because of the previous session where we were developing. We created that directory to develop, to practice developing CGI scripts. If it's not there, it's fine. It'll get created. So if you look, yes, so this is just if you look in the Git repository, HTML, you'll see admin index. We have our own index. Yeah, the scout picks and the upload. So I'm just looking around, but this is the command you want right here. Sudo copy. The -r says copy recursively, which means copy directories and anything in directories all the way down recursively until you get all files. So this says, as a super user, copy everything in the www directory. You can see I'm in the Web Scout 2020, so I'm in the infinite recharge. Copy everything in this directory into /var. And that will copy www into /var and all the files in it. And that effectively installs the scouting app and makes it available for serving by the web server. So once you do that, then you will get this page back to start. So if you go to your Raspberry Pi, I have two Raspberry Pis. So this is .73. And if I don't type the index.html, you'll see it just shows up. You'll get this page. So the scouting app is now live and functional. Come back here. Before we play with the scouting app, I'll just come back and talk about one more setup. But now that you have the scouting app set up, this talks about how you can delete match data. So you won't get any match data when you pull from the GitHub repo. I don't think we uploaded any match data there. We try to keep the GitHub repo clean of scouting data and match data. But maybe there'll be some match data. If you need to delete it, like we had two versions of week 0, we were still trying to figure things out. This shows you how you can delete match data. So you cd into this var www cgi bin match data directory, and you delete the file in there, and that'll get rid of the match data. Okay, one last step that I'll cover here before we play with the scouting app, and that is if you want to take this scouting app now to a competition, you need to configure the Raspberry Pi as a DHCP server, because you can't, you're not going to be able to connect to the host Wi-Fi. You have to create your own network, and you want to serve. You're going to. We do this so that the Raspberry Pi serves IP addresses to the tablets and to a laptop if you want to connect a laptop to it. So to do this, we're going to install software on the Raspberry Pi and configure it to create its own little, private network. So this talks about DHCP. We already covered that. To install it, again, if it's been a while, refresh and upgrade. But if you just did it, you can skip those steps. And then here's the command you're going to want to run to install it. The app is ISC DHCP server. So install that, accept the prompts, and then that will install the service. It won't start it, which is a good thing. We don't want it started, but because we need to configure it first, it doesn't know what it's serving. So if you cd into etc dhcp, which will now be there because you've installed the app, you will see a default dhcp.conf file, and it has lots of examples and comments on how to configure a DHCP server. We're going to move that aside, save that, because it'll be good for reference if you want to play with your DHCP server, have it do different things. You'll have this documentation handy. But we're going to create our own. So um, run sudo emacs-nw, create our own copy of DHCP, and you can populate it just as I've populated it here, and we can discuss some of the comments. So just a comment to describe what the file is here. Default lease time and max lease time. So this is how long a client is allowed to use an IP address before it has to request another one, before we as the server are gonna take it back and make it available to anybody else who wants it. Um, so this is set to, got to do the math. Is it an hour? It's in seconds. What is it? 600, 300? Yeah, it's probably somewhere like an hour. So this is fine. Maybe we should, yeah, if that's an issue, you might want to lower it. But this should be fine. So those are fine. You don't need to change those. This command just says we're not doing anything. We're not doing any domain name server interactions. So turn that off. We're just going to be serving IP addresses. So you're not going to be able to, in the tablet, you're not going to be able to say, hey, 1073scoutingapp.com, let's go. It's not going to do any resolving of names. It's only going to serve IP addresses. And then here is where you define first your subnet, and so this is one way to configure it. If you want to configure the subnet with the same subnet, so I set this up so that I could serve a group of IPs on my same home network as my router, but I don't want to interfere with my router. So um, I said, okay, the subnet is the same as my home network, 192.168.1. That's how you denote a subnet, is the 0 is what's open. And again, the net mask, like we talked about, written in IP address format, 255, 255, 255, 0. So when you overlay these bits over this, you get an IP address. And then we define the pool of IPs that we're going to get out, or the range of IPs. And what I said here is let's give out IPs from 200 to 220. So we're going to give out 21 IP addresses. And that's plenty more than we need. I could just make it, 6 or 7 if a laptop wanted to join. But I'll make it 20. And this does not interfere with my home network. And then I said, I set this option router to myself. So this was I configured this on the Raspberry Pi where I gave it the .75. I just say I'm your router. So put in the IP address, whatever IP address you want. I'll say actually for our scouting app, what we ended up doing is, because this is our own network, you can create it any way you want. We set up the subnet to be 10.73.10.73. And we thought that was kind of clever, because then when you go to the competition, you just tell the scouters, hey, make sure the browser's pointed to 10.73.10.73, and it was an easy number to remember. If with this case, in this configuration, you would tell your scouters, start up your tablet, launch a browser, and point it at 192.168.175. But if your team number, you have to break up your team number to fit within under 255, but you can get creative that way. And so we set our subnet to 1073. The range was 1073, 10, 1 to 20, because those IPs are going to go out to the tablets. So we don't care about those. The number that matters is the static IP of your Raspberry Pi, which also means you have to go back to in the configure a static IP address. We change that so it's not a 192.168. We change that to 10.73.10.73. And that gets tricky because now you can't plug that in. You need a 10 network to plug that in. So Our actual scouting app Raspberry Pi is now its own network always, and you can plug a laptop in and it'll give the laptop an IP address, but if I wanted to connect it back to the internet, I would need to go in and change that static IP back to something that fits with um, my home network, for example, if I brought it home, or the team space if we were at the team place. So that was just an elaborate kind of aside to talk about what we did. But it's just to show you, your Raspberry Pi network is yours. You can set it up any way you want. This way is probably most convenient because now you can take the Raspberry Pi to a competition, come back, plug it in at your home, download data, update apps, things like that, and not have to go in and change things. And that's what this does. So that talks about configuring it, and then the next step is when you want to start this, um, and how to set it up. So right now, the DHCP server does not start by default. There are commands you can run. Sudo system control is the command, and there's an argument. You could do status and then the DHCP server service, and it will say not running, right? Not enabled, not running at the moment. If you were getting ready to go to a competition, you would want to run this command before you shut down the Raspberry Pi. You want to enable it. And this means when it's enabled, it means when it boots up, when the Raspberry Pi boots up, next time it boots up, it's going to start the DHCP server automatically. So that's what enable does. Um, then if you want to disable that when you come home, you would type disable. It's right here, sudo systemctl disable. So if you went to a competition, so you enabled it, and then you shut down the Raspberry Pi, went to the competition, it booted up automatically, served IPs to the scouting tablets, you gathered all your data, um, and then you shut it back down, you finished a competition, you brought it home. When you connected it back to my home network or your team network, you would want to log in, and the first thing you might want to do if you're done with the competition is disable it. If you just want to turn it off, you can run stop. This is how you would turn the service off. But if you were done and your next competition wasn't for a couple of weeks and you wanted to keep the Raspberry Pi up and running, or need it to survive a couple of reboots, you might want to disable it so it doesn't come up automatically. So that's what this section does, is it gives you the commands to to control that service, and you need to be mindful of it, because if you leave it enabled and then you plug it into a home network, somebody comes in, they're going to request an IP address. They might get one from my router. They might get one from the Raspberry Pi. And so you don't want that conflict, because then when you shut down the Raspberry Pi, your app, your phone, or whatever might go, hey, where'd my where'd my IP go? So it won't be harmful. It'll just end up asking your router for a new IP. But having two services like that, I honestly haven't done it. I don't know if you'd want to try it. Okay, so that's it. That's everything you need to know to set up and manage a scouting app. So the last thing is day of the competition. How do we use this? So there's a little link right here for head scouters. So if you're at a competition, you've got the thing up and running, your scouters are ready to go. The first thing you need to do is add match data. So the head scouting page, there's configure an event, and this is for events that are not in Blue Alliance. If you go to off season events, those typically aren't posted on Blue Alliance unless they're a big event. This is where you have to get the sheet, come back, sit down, and type in your matches. Who's R1, R2, R3. We've had to do this for a couple of off-season events here in New Hampshire, because the matches don't get uploaded to Blue Alliance. So there's usually only 20 matches or so. So you're going to sit here, type it all in. We recommend, so you can see here, year and venue. And we recommend, if possible, if you know it's going to eventually be on the Blue Alliance, we recommend trying to match the keywords that Blue Alliance might use. So you noticed, if I go back and go to start scouting, this is the keyword that a Blue Alliance would do. It would go year and then location. So New Hampshire events are always New Hampshire, and this is Granite State, or um, I can't think of any of the other keywords, but it'll be Mass, Reading, things like that for the Reading event in Mass. WPI. I don't know what the keyword is for that. Hopefully it's WPI. But you'll see that on Blue Alliance. So try and match that. So let me jump back here. Sorry, I hope the me being so active is not coming across too jittery in the stream. So here is where you would put in year and event, and then you would fill out, you can make up your own venue, Bob, if you're going to Battle of the Bay, um, you know, RR for River Rage. Any off-season event you go to, you can make up the venue. You don't have to match Blue Alliance, but the advantage of matching Blue Alliance is you can get the match schedule from Blue Alliance and add it, and it will line up with all your scouting data. Um, Otherwise, yeah, there's plenty. We made this plenty big enough. You don't have to fill it all out. Just fill in what you need. Save the event, and that will show up. Now you could, excuse me, have your tablets go to the start scouting page, and the event will show up. But a much better way to do this is to upload the match schedule from Blue Alliance. So this is a little tricky because your Raspberry Pi is on its own Wi-Fi. You're not connected to the internet, so you can't just go to Blue Alliance. So what we do is you take a laptop, you get on a hotspot or a Wi-Fi at an event as soon as the match is uploaded and available. And the instructions are here. I apologize if the text is a little small, but it says, get on the internet, go to Blue Alliance and select the event. Right click on the match schedule. So go to Blue Alliance. Let's try this. Go to Blue Alliance. Pick an event. Events. Let's go to 2019 event. Or yeah, no, we can go to well, there weren't that many 2020 events. That's why. All right, let's say we want to go to the robotics festival. Here is the match schedule events. Here's all the matches. Now there's results in here, but normally there wouldn't be. What you want to do is right click on this page and view the page source. And the reason for that is now we're looking at the HTML, and the HTML structures the data a certain way that makes, we wrote a program to be able to read this HTML and find the information we want. So once you do this, I'm going to press Control A and Control C, and now I've copied the entire source of this web page. Now I would take this laptop, unplug it from the hotspot, plug it into the Raspberry Pi, and that's what's described here. So it says select view page source. On the page source, select all of the content and copy. Connect to the scouting app, come to this page, and in this box, I'm going to do Control V. And there's all of the content from that Blue Alliance page. And then I'm going to click Upload Event. And it says the match data for 2019 QCMO successfully stored. I should increase the font on this, but that's what it says. Now if I go home, I start scouting, and look, here's the event for Q 2019. This is a 2019 event in a scouting app for 2020, so this is going to look funny. But if I click on that as a scouter, and if I'm R1, here are the matches, here are the robots for that match. I'll start scouting match 1, and here we go. So that's how you can upload match schedules, and that's much more convenient than trying to type it all in. Okay, I've only got a few minutes. I think I've pretty much covered everything. Again, the value of the scouting app here, the analysis. So here's all the data we collected from the Granite State event last year before everything went south. We went to the event, tested out the scouting app. You can see the value of the scouting app is you have all the data automatically concentrated in one location. So actually, if you go back home, so if you want, everything is stored in this CSV file. So this looks like an eye chart. It's very small, but it's a comma separated value file, and this is useful because Excel spreadsheets can read this, other spreadsheets can read this, Tableau can read this. Um, so this is how our scouting app stores data. So whoever scouted right here, whoever scouted the PVC Pirates, here's how well that robot did for this qualifying match 64. Um, these numbers represent, the different columns which are described up at the top. And so so each line is a robot in a match. And by having all that information there, we wrote a couple of programs to parse it and display it. So that's what this analysis page does. We It displays all the data. We calculate it by the points described in the game manual, and we come up with an OPR. And we can sort. So by default, the teams are sorted by OPR here. But if you want to know who was the best at teleop shooting into the inner port, you click on that. If you're looking for a robot that can do that as part of a pick list, 5687, we saw the matches that we scouted, they were the best. They were able to get 4 shots into that inner port. So climbing is in here. Our strategy team got together and decided what was important in the scouting app and created this. And then the last feature I'll show, which is really cool, is once you have a day or two of data, on the last day before elims or even for elims, we created a prediction, a match predictor. So you can pick 6 teams, and what this will do is it will go get its OPR, recalculate its OPR from that raw data, and combine them, just add them up. So if these 3 teams had to play these 3 teams, it looks like the Blue Alliance would win by roughly 30 points. And so if we were one of the Blue Alliance teams, we'd look up here at the Red Alliance team and say, well, it looks like team 1247 is a robot we're going to want to watch out for. They can score a lot of points in this match. Let's see if we can slow them down, or you can do all kinds of analysis. And the match predictor is fun because you can set it up during elims and see how close your scouting data is to reality, because that's really what this is all based on, is just how well your scouters collected data and how well, um, you know, a- a- if the robot is consistent, or if alliances um, were selected correctly and really enhance the capabilities of the teams. Maybe they end up doing better than what we saw them do during the qualifying matches. So it's kind of fun, but this is the kind of neat stuff that your developers could play with in the scouting app. It's what we came up with. So I hope I covered everything on how to set up and run the scouting app. I'm gonna take a look at the questions. Hopefully I left enough time for questions here. Oh, okay. I don't see any questions. If you want to type in a question, go for it. Um, Otherwise, uh, that's it. I think I've covered everything on how to run your own little uh, private network and get a scouting and have a web-based scouting solution in play at any events. I know, unfortunately, we're not going to be able to do any of that this year, except maybe Michigan or other places that are able to do it. Hopefully, we'll get some matches around here. But this can be useful when things hopefully get back to normal sooner rather than later. All right, I'll give one more check to the questions. All right, I don't see any questions, so unless anybody wants to speak up or type quickly, I think I'll wrap up and give everybody a chance to get a quick break before the next session. Thank you. Take care.
Propel